Chapter 12, Section 12.1, 12.2, and 12.3. First, we talk about the sample size, mean of the sample, standard deviation of the sample, mean of the entire populations, and these are the symbols that we use. Like for mean of population, we are using this Greek letter mean. For mean of the sample, that's what we use. And for a standard deviation, if it's a standard deviation for population, we use this sigma, and if it's a standard deviation for the sample, we are using this S. So there are two letters we use for mean and two letters for standard deviation, and N for the sample size. Again, I took these notes from one of our professor, Powell. When the purpose of statistical study is to learn about the population mean and sample mean of X bar, can be used as an estimate for mean. So if you want to calculate population mean, you could take the sample mean and then we use some formula to get a result for mean of populations. With a normal curve, normal distribution, mean always is in the center. And in these pictures, you could actually see that the standard deviation used the variety of the numbers and how the number is spread out from mean of populations. So what we normally do here is you're taking, if you want to calculate mean of populations, what you do is you, from one place, you take many samples. First, you want to make sure that all the samples that you're taking, they all have different size. I mean, same size, I'm sorry. So if you take 5 samples from one corner of this area, you have to take 5 samples from the different areas. So what we do is, let's say we want to calculate, mean of population for proportion of the income. We want to know what the proportion of income is for median family in one big city. So what we do, we are taking many samples. For each samples, we calculate the mean. And that's why we use this letter bar, means is indication of the sample mean. Then we always claim that when we take all these samples and we take an average of those, then the result is actually equal to mean of population, the one that we're looking for. And what you want to do is you want to take many samples and you want to make sure you take a large sample, at least 30 instead of 5. But anyway, this is what you see here is mean of all the samples that you're taking. And the vertical is the density. And what is the density? Density is, this is a density histogram. Density is relative frequency divided by interval of width. That would be the vertical columns, and horizontal column is the sample mean that we calculate for each, mean for each samples. And here, each of the histograms is normal in shape and is centered at approximately 8.3. So they all have mean of 8.3. But what we want to show you here is when the number increase, then your curve or histogram is getting closer or is getting close to the mean. So you get a better shape. It's not spread out like this one. See, the numbers are spreading out, but here numbers are getting close to the actual mean here. So that means you need a larger sample. At least 30 is a good number. So what do you notice about the mean of this distribution? Mean is the same. They all have the same mean, 8.3. And then here, what do you notice about standard deviations? As n increase, a standard deviation decrease. This is a formula for standard deviation. So n is a denominator. When n increase, then the entire fractions decrease, and that would impact the standard deviation, and the standard deviation decrease. So n increase, you have a larger sample, you have less variations. So variation is less, means the number is getting close to the actual mean. See how a standard deviation here in this example show the variations? So you can imagine if the number is getting, if the standard deviation is smaller, it means numbers are getting closer to the mean in the center, and that's what you want. What do you notice about this distribution? They all are normal. They have this bell shape. When you see this bell shape, it's kind of normal shape. When we say distribution is normal, when you have a case like this, then the histograms are increasing and then fall and reach to the bottom. Now, the original one is not a normal, right? Well, when you take samples, as the sample increase, in this example, they want to show you that when you actually increase the samples, then the function is getting close to the normal. See, are these distributions similar at mean 13? Yes, they all have the mean of 13. What do you notice about the shape of this distribution? Approximately normal. They all are getting a normal shape. And what do you notice about the standard deviation of this distribution? As n increase, standard deviation decrease. Means, you see here, n is 30 versus n 20. You see how all these numbers are getting close to the mean, and is not as, the histogram is not as wide as this one. And then this is another example. If this is the actual population is this, as n increase, the graph is getting skinnier and it's getting better shape of the normal. And you could actually see that here. See, population, the original population was not normal, was a skew to the right. You see that? You're going like this. But as the number increase, the shape of the graph become normal. So this was the original one. It was like this. And now, as the n increase, it becomes normal. Bottom line is n has to be greater than 30 in order to claim that it's normal. And there is an example here that in a study of courtship of mating scorpion flies, X is a courtship time. So what it is, the mean of the samples always is equal to mean of populations. But the standard deviation is the standard deviation given the problem divided by radical n. N is number of samples. So here, mean is equal to 117.1. But if you want to calculate the standard deviation of the sample, you got to take this one and divide by radical n, because there were 20 of them. See, standard deviation is 109. And there are 20 scorpion. So we divide by radical 20 to get the standard deviation. Do you think distribution is normal? Since standard deviation is long, population distribution is skewed, so there is no reason to believe that distribution is normal, because it's large, it's very large one. You remember, as if the n increase, the standard deviation decrease, so it'd be better to have a smaller standard deviation, because the standard deviation shows the variations, how the numbers spread out from the mean. And here, the rule 4 is our sample size is not large enough. The sample was 20. You always want to have 30 or more in order to claim that distribution is normal. So here, Informations are given in the problem is this, in this example, a hot dog manufacturer claim, they claim that dogs has a mean fat of mean equal 18 grams per hot dog. So this is their claim. So original claim happened to be HO in this case. So original claim is HO and HA is opposite. So if you want to reject the claim, we have to prove that mean is greater than 18. This is what they claim. Since it's the equal sign is always for HO. But for alternate hypothesis, it has to be opposite of this, which is greater than. That's how to determine your HO and HA. Now, what they ask us to find is standard deviation of the sample. The standard deviation is 1, but since you have about 36, n is 36, then the standard deviation is found from this formula. You have to put radical 36 here. So the standard deviation of the samples is 1/6. Standard deviation of the X distribution is 1/6. Sample size is 36. Assume that means of all the samples are equal. Remember, mean of samples is always equal to mean of population. So we don't have to calculate the mean of population because we assume that mean of samples, then you take the sample, when you take so many samples and you find a mean, average of those would be equal to mean of population. So if mean of population was 18, mean of samples also is 18. But now we want to calculate the value of this Z. If you want to use the formula is mean of sample minus mean of population divided by standard deviation over radical N. So here, mean of sample is given in the problem is 18.4. Mean of populations is 18. And then a standard deviation divided by N, we already calculate that, is 1/6. That gives you the value of Z. We want to find probability of Z greater than the result of this. When we do the calculation, then we find this, the outcome is 2.4. So when you calculate Z and put the numbers into this formula, Z is 2.4. We want to know what is probability of Z greater than 2.4. Probability of Z greater than 2.4 is really, really small, it's 0.0082. So in that case, value of X sample mean as large as 18.4 will be observed only about 0.82% of the time, when random sample of 36 is taken from populations. What does p-value tell you about the matter? We should be skeptical of the manufacturer selections. Okay, so probability of fat B greater than that is really, really small. Now here, if you don't want to do hand calculations here, okay, then I show you how to use a calculator. If you want to, if you use a TI-84 calculator, you go to t-test. And when you go to t-test, then you have to input those numbers. So you go to stat, you go to test, and then to, let's say, t-test. You have to put all the numbers here. Mean is like 18. The numbers are from previous problems. Sample mean is 18.4. Standard deviation is 1. Standard deviation of sample, N is 36. You know, these three, they always take symbol of HA. If you don't know which one of these three you have to select as far as the symbol, when it's not equal or less, or always look at alternate hypothesis, which in this case is this one. The symbol of HA, or alternate hypothesis, this symbol, which is greater, that is what you need to use in the calculator, which we already have it here. So then it gives you the value of t, which is 2.4. And I have it here. The p-value, this is a value that you always compare with alpha, which is 0.01, okay? Even if you want to do the calculation for this part, let's say you want to find probability of z greater than 2.4, which give you the area. See here, if you want to find, if you don't want to do the hand calculation, what is the probability of z greater than 2.4? That means, what's the area on the right side of 2.4? To find that, you could either use the table or you could use calculator. Calculator require 2 endpoint. One endpoint is 2.4. For the other one, when the graph goes beyond 3, is getting really, really close to the horizontal axis. So we normally use 10. So that's what you hear. You go to second verse, normal CDF, and then parentheses Z1 comma Z2. Z1 is 2.4 is on the left, and on the right, this is an arbitrary number, 10. So that would give you that 0.82. So if you want to calculate 0.0082 with the calculator, that's how to do it. Calculator always require 2 endpoints. So for any area you want to use the calculator, if you want to find the area, you need 2 endpoints. One endpoint is given 2.4. The other one, you could always use the arbitrary number of 10. If it's on the left, you could use -10. All right, so, and then if the p-value, we find the p-value, if the p-value is less than alpha, we always reject HO. If the p-value is less than 5%, we reject HO. If p-value is greater, then we accept HO. We do not reject. Now, if we ask you to find interval for the mean, the formula is this. Confidence interval for the mean is sample means plus E sample means minus. What is E? E is the margin of error. Sometimes we use the E, or we are using M. If you use the M letter or M or E, some textbooks use E for the margin of error, some textbooks use M. Both means margin of error, which is Z times standard deviation divided by radical N. And you could also do that. I show you how to use a calculator. If you see, the numbers are given. Standard deviation is given, N is given, sample mean are given. These are all given in the problems, okay? If you want to use the calculator, you gotta go to Z interval, number 7. So you go to number 7. Again, all are in the test. Number 7 here is Z interval, see? They ask you for all those information, standard deviation, which we have 35, and these are from the previous problem. So you put all those numbers here and you calculate, okay? So that's for this one. And then t-distribution. The next is, instead of Z, we are using t-distribution. Just as there are many different normal distribution, there are also many different t-distribution. While normal distribution are distinguished from one another by their mean and standard deviation, the t-distribution correspond to any particular degree of the freedom, is bell-shaped and centered at the 0. Every t-distribution has greater visibility. The number of degree of freedom increase. The corresponding sequence of t-distribution approach the standard normal distribution. Here in this example, they want to show you the Z curve and the curve which is related to t. to find the t value instead of z value, you need a df. As df increase, then the function, the shape of the function getting close to the z curve. You see that? See, t curve for degree of 4 is this, but when the degree from 4 goes to 12, then the shape is getting close to the z curve. This is comparison of the standard normal z and t distribution. Now, when do we use z versus t distribution? That depends on a standard deviation. If a standard deviation, this is a symbol for a standard deviation of population. If a standard deviation of population is not given in the problem, then you are using the t. If a standard deviation is given, then you're using the z value. So, and we also have we have a table for z, and we have a table for t. Or you could use the calculator to find z or t. But t is normally used when a standard deviation of population is not given. As you see in the formula, there is S. What is S? A standard deviation of the sample. So obviously, when a standard deviation of population is not given, you must have a standard deviation of sample in the problem. A standard deviation of the sample and mean of the sample. See, these two are samples. Mean of the sample, standard deviation of the sample. Mean of population, a standard deviation of population. These are the symbols we use for mean of population and standard deviation of population. Again, they show you that when df increase, go from 2df to 5df, the function is getting close. And this is the table that we use for the t. I have a copy of that later on, but I think it's easier to use the calculator if you want to find the t. To find the t, you need two numbers. One is df, which is n minus 1. Degree of freedom, they call it, is n minus 1. You subtract 1 from n. And area of the tails. You need area of the tails. And then when we go to the problems, I show how that's work. So these problems, they ask us to find the interval for the mean. Remember, is mean plus margin of error, mean minus margin of error. Now, there are two conditions for you before you actually use the formula. If you want to use the confidence interval, you must have these requirements. Either n has to be greater than 30, or we should indicate if n is not greater than 30, but we indicate in the problem that population is normally distributed, then you're allowed to use the formula. So you're allowed to use this formula if population is normally distributed or n greater than 30. So in the problem, if you see n is like 20, don't assume that we cannot use it. If we indicate in the problem that population is normally distributed, then it's okay to have n less than 30. Then you could go ahead and use the t formula, okay? So t formula, again, is used when the standard deviation of population is not given. So for all the problems, we have estimation, we have the sample data, we had one numerical, one samples, n has to be greater than 7. You always have to have random samples. Sample has to be randomly selected. So when you want to take some samples from one large area, it has to be random sample. It means you should, you randomly select 10 or 15 samples. You don't specify where you should take it. It's a random. Okay. And again, in this example, it's the same thing. I'll show you how to use the TI-84 to find, if you want to calculate the t value, and you want to use the calculator. If you want to use the calculator, so in that case, what you need to do is you go to the second verse, INVT. I'll show you here. Second verse, and then you go to inverse t. This is for finding a t, inverse t, okay? What you have here is, in these problems, is a 95%. When is 95%? That means area of both tails is 0.05. Area of one tail is 0.025. So to calculate inverse T, you need to put that alpha, which is area of one tail here. That's why we put 0.025. This is in case of two tails. In case of two tails, for inverse T, you have to put area of one tail. Two tail is 0.05, but one tail is 0.025. And the second number is the DF, which we have 37. So we put 30. DF is 36. N was 38. N is 38. DF is 37. You have to put DF here. So inverse T, we use alpha or alpha half and DF. If we ask you to calculate the N, if the number of sample is unknown, this is the formula. 1.96 times a standard deviation of the sample times margin or divided by margin of error. See, I put it here. If sample size, if you don't know how many samples you need to take, if that is unknown, you need to have margin of error, M or E, standard deviation of the sample, you need to have that, and also you need to have T, which normally we are using 1.96 for the TY because most of the problem is 95%. The reason we use 1.96, this is the T for 95%. In the problem, if it's different, then you have to calculate. But normally we have 95% and the T is 1.96. That's how to calculate the sample size. And here I show you how to use the calculator to find the T interval. If you want to use the sample size, we need a standard deviation of population, but the standard population normally is not given. If it's not given, you could use this formula. This is the quick way of finding a standard deviation. Range divided by 4. Range is highest, and you take the highest and lowest number and subtract. That's the range. Divided by 4. You find the standard deviation is 100. Okay, you have that 100. Margin of error is given in the problem. See, margin of error is 20. So you put those numbers here. Margin of error, 1.96, 100, and that gives you the sample size. So this is a formula for sample size. If you have a right tails, you have a left tail and two tails. I'll show you here. T formula, this is a T formula. We already had that. If you have a bunch of the numbers, you need to calculate mean and standard deviations. For that, I think you could use the calculator easier. Remember L1, what you do is you take all these numbers, like here, let me show you another example here. This is not related to these problems, but if you have a bunch of numbers and you want to calculate mean and standard deviations, you go to edit. You put all your numbers, like this is for the different problems. You put all your numbers here. I put everything on L1. Again, this is for different problems. You list all the numbers here, and then you go to stat. You go to calculations. The very first one where is stat? Enter. It asks you where is your data. You say my data is L1, so you don't have to do anything here. You want to make sure all your data is L1. Calculate. Doing that, you find your mean and a standard deviation, SX. Don't worry about this sigma, SX. S and mean. That's how you calculate your mean and the standard deviation. So for a problem like that, you take all these numbers and you put into L1, and then you follow that instructions. So all these problems are very similar. You know, you have instruction on how to go to t-test and find the p-value and the t. P-value, again, if the p-value is less than alpha, which is given in the problem is 5%, then you always reject. If p-value is less than alpha, you reject HO. If your p-value is greater than alpha, you always accept HO. It means you do not reject HO. Okay, so you remember that. You could find the p-value to the calculator. If the p-value is always greater than alpha, which is given in the problem, normally is 0.05, and that's for 95% confidence. 1 minus 0.95 is 0.05. You like accept HO or you do not reject, or just say accept HO. That means you do not reject HO. But if your p-value, when you calculate, is less than alpha, then you reject HO. So if you have a null hypotenuse and alternate hypotenuse at the end, when you find a p-value to the calculator, always compare that with alpha, which is 0.05. Again, if it's greater, you always accept the HO, and if not, you reject HO. For HO, you always take an equal sign, but alternate hypothesis can be one of these three. So this is another formula, how to calculate the p-value. If you want to use the p-value, you could either use the formula or you could use the calculator, okay? So right after all this, I have done the homework for you, so you could go ahead and work on the homework for section 201, 202, 203.